from all land, the ocean, which covers more than half the surface of our planet, and yet, for the most part, it is beyond our reach. Much of it is virtually empty, a watery desert. Oceans cover more than 71% of the Earth's surface. We currently recognize 5 of them: the Pacific, the Atlantic, the Indian, the Southern Ocean, and the Arctic Ocean. Each one of these oceans can be divided into 3 sections. First, there is the coastal region, then there is the continental shelf, and then the deep sea. The largest of the oceans, the Pacific, covers 28% of Earth's surface. It is essentially cut off from the Arctic Ocean, but connected to all others. The Atlantic, second largest, is roughly half the size of the Pacific. The North Atlantic is dominated by a clockwise warm water Gulf Stream and its northern extension. The North Atlantic Drift, forming the eastern boundary, it has a connection to the Arctic Ocean. The Indian Ocean, this body of water is still larger than the largest landmass. Regions of the North Equator are strongly influenced by the changing winds and directions of the Asian monsoons in this ocean. From December to April, winds and ocean currents flow from the northeast from June through October. Both move in a southwesterly direction. The Southern Ocean, these cold waters recognized as a separate ocean since 2000, encircle the Antarctic continent. Northern limits have been set by the International Convention at 60 degrees south latitude. Its surface area extends over 7,927,500 miles. The Arctic Ocean is almost the size of the Antarctic continent, at the opposite end of the Earth. Due to the ocean's large size, temperature and precipitation vary greatly. Water can be as warm as 36 degrees Celsius or 98 degrees Fahrenheit, or as low as -2 degrees Celsius or 28 degrees Fahrenheit. This means that precipitation can range from over 90 inches to over 200 inches a year. The Arctic and Antarctic seas hold the coldest water in our Earth, and the Persian Gulf, which is located near the equator, can be the warmest at almost 100 degrees Fahrenheit.
While the ocean floor may look like simple sand, it is actually made up of 3 types of soil. Calcareous ooze is the most common of the 3 soils and covers 48% of the ocean floor. It is composed of the shells from Foraminifera, Coccoliferae, and Pteroids, which are tiny organisms living in the ocean. Red clay covers 38% of the ocean floor and is brown. It is made up of quartz, clay minerals, and micrometeorites, which are rock that weigh less than a gram. Siliceous ooze is the least common soil, covering only 15% of the ocean floor. It is composed of plankton, debris, and silica shells.
This depicts a typical food web in the marine biome. In this biome, the producers are represented as the diatoms and the tiny water animals. The krill and the squid eat these producers and are therefore known as the primary consumers. Larger fish, penguins, and leopard seals all eat the smaller fish in the sea. Fish eating fish? Crazy, I know. Leopard seals, killer whales, and penguins all eat squid. Penguins are less secondary consumers, for all they eat is mostly primary consumers. Killer whales and leopard seals would be considered tertiary consumers, and thus they are at the top of the food web. In this energy pyramid, the energy is dissipated between each trophic level. First, the producers obtain energy from the sun. These producers include fauna such as phytoplankton and seaweed. Next, the first level carnivorous consumers such as jellyfish, small fish, and other animals all eat these producers. The energy is therefore dissipated between the primary producers and the first level carnivorous consumers. Next, larger fish will eat these first level carnivorous consumers, again, there is an energy transfer between levels. At the top of this energy pyramid, we see third-level carnivorous consumers and top carnivores. These animals include squid, shark, dolphin, and other animals. These have the least energy because since the bottom of the energy pyramid, the primary producer's energy has disappeared. Throughout this process, energy is also lost through heat energy and energy lost to decomposers. This energy eventually goes back into the energy pyramid to the primary producers.
Now we will examine some of the fauna of the ocean biomes. First, sharks. There are many different types of sharks and each has developed their own special adaptation to live in the different areas of the ocean. For example, great white sharks are larger and faster than most others and are able to eat almost anything. The next type we are going to look at is the bull shark. The bull shark is the only shark that can swim in both salt and fresh water. This special adaptation has allowed it to gather more food than most other sharks because it can swim up rivers and catch freshwater fish. The next animal, zooplankton, is perhaps one of the most important animals in the entire ocean. These small animals live near the surface and are many different types of animals such as the larvae of larger animals, fish, crustaceans, and small shrimp-like creatures. These planktons provide the basis for the ocean's food chain along with phytoplankton. They are consumed by other animals like larger whales. The final type of animal we will look at is the octopus. There are more than 300 species of octopi recognized, and which is over 1/3 of the total number of cephalopods species. Each type is different and adapted to different marine environments. For example, this octopus here can change colors and lives in the reefs and is small enough to catch fish. This second octopus is perhaps the most strange animal in all of the ocean. It is known as the vampire octopus. Not only can this octopus turn itself inside out, but also uses bioluminescence on the end of its tentacles to attract prey and eat them. It has adapted this strange feature because unlike the previous octopus which lives on coral reefs, this octopus lives in the deep depths of the ocean where almost no light can penetrate. Now we examine the flora of the ocean. First is phytoplankton, perhaps the most valuable of all organisms in the sea. These are photosynthesizing, microscopic organisms that inhabit the upper sunlit layer of almost all oceans and bodies of freshwater on Earth. They are agents for primary production, the creation of organic compounds from carbon dioxide dissolved in the water, a process that sustains the aquatic food web and all life in the ocean. The next and most well-known sea plant is seaweed, which refers to several species of macroscopic multicellular marine algae. There are so many different types and can be found all around and at all layers of the ocean and in brackish water all around the world. And lastly, the largest of all sea plants, kelp. Closely related to seaweed, but not the same, kelp is the largest type of ocean plant and the fastest growing. They have adapted to form large kelp forests and can grow up to 250 feet long. They mostly grow in cool waters, but have also adapted to be found in tropical waters as well.
You have learned a lot about the marine biome, and now it's time for you to get out and explore and dive into the Basque Beach